These streetlight poles are made of what's called composite, a combination of fiberglass and epoxy resin. Epoxy resin is a gooey liquid plastic mixed with a hardener. The factory constructs each pole on a mandrel, a long tapered metal cylinder. Workers first lubricate the surface. Then they take what's called fiberglass filament, a string composed of 2,200 tiny fiberglass strands. They'll wind dozens of filaments around the mandrel to create the pole. But first, the filaments go through a bath of epoxy resin. This resin is moldable, and once it's heat-cured, maintains its shape. Once the filaments come out of the bath, a machine called a filament winder wraps them around the rotating mandrel. The speed of rotation in relation to the speed of the winder is critical because it dictates the angle of the fibers. The lower the angle, the more that part of the pole will be able to withstand the wind and provide constant, stable lighting. When a pole bends in the wind, the light appears to flicker. The number of filament layers depends on the design of each specific pole, and that's determined by a couple of factors. First, the type of light fixture the pole will hold. The bigger the fixture, the stiffer the pole has to be. The other factor is wind. The windier the location, the stronger the pole has to be. Once the winding's done, the mandrel moves on to the curing station. They pump pressurized steam into the hollow inside of the mandrel. The heat kickstarts the hardener in the epoxy resin. This solidifies the resin and cures it. The mandrel rotates so that the pole cures evenly. Curing time depends on the length of the pole and how many filaments it's made of. To help extract the pole, they pump cold water through the mandrel. This makes the steel mandrel contract, loosening the pole. Remember how workers lubricated the surface of the mandrel before winding the filaments? Because of that, the pole just slides off. The pole now moves on to the finishing stages. First, an automated sander works the surface. The customer can order from a choice of surface textures, from smooth to rough. Sanding takes just a few minutes. Now a saw makes a neat cut at the top of the pole where the metal tenon will go. A tenon is the component that'll hold the light fixture to the pole. This particular model has an arched mounting arm. The composite has cooled a bit since curing, so they reheat it to make it flexible. After a bending machine makes the curve, they spray cold water inside to cool the material. This registers the curve in the resin's memory, setting the bent shape. Now they cut out the hand hole, the opening through which the electrician will connect the underground wire to the fixture wiring. Workers then spray the pole with urethane paint. The paint acts like sunscreen, protecting the composite from damaging ultraviolet rays. This grommet hole will connect to the underground pipe that contains the electrical wires. After installing a cover over the handhole, it's time to assemble the parts. The underground pipe to the pole, and the pole to the tenon and light fixture.